Semester Project, Computer Organization and Architecture, Department of Computer Engineering. Project Title: Design and Implementation of a Verilog-based RISC-V CPU with a custom assembler for executing user-defined assembly programs. This project presents the design and implementation of a custom RISC-V verilog HDL, developed for educational and experimental purposes. The CPU follows a 5-stage architecture, including instruction fetch, decode, execute, memory access, and write back. A custom assembler was also developed to convert user-defined assembly programs into machine code, which is executed directly on the CPU using Modelsum. The processor supports multiple instructions such as add, sub, load, store, and branch operations. Several programs, including Fibonacci, array summation, and sorting, were successfully executed, confirming correct functionality. Overall, this project demonstrates effective hardware-software code design and a strong understanding of computer organization and architecture principles.